we can start from question number 3. So the following data is an extract of some test results of 2215. So
Okay.
BA students these are numbers, of people from 1 through to 10, and this is what they called actually. This is what they called their 10 students altogether. Can you compute the mean, the median, the mode, and use them to describe the distribution of data? That's the question. So how do we get to find the mean? Okay. How do we get to find the mean? What do you think we can do?
We add then all the number the score, the quiz score numbers.
The scores, right?
Then yes, the scores, yes.
Then
We divide them by how many they are. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
By 10.
Yes.
Right. Okay. Then the median, how do you find the median?
The median, we arrange them, I think, from the smallest to the largest number. Then we add the middle numbers divided by 2.
Let's try to arrange them. So we start with 2.4. What follows next?
30. Is it 30.5?
In order of importance, 2.5, then you can come to 10.
I can't see clearly. There's 2.5. There's no 2.5. There's 2.4. Yes.
At least now we have zoomed. You can see, right?
Yes, I can see.
So it's 2.410. What else? 15. 15.
Yes, 15.
Another 15.
Then 25.
25.
Yes.
Then
And 30.
30. And 30.5.
30.5, then 40.
40. And the 80.
80.
Right. That's how to find. Now, we need to find the median, isn't it? So we can strike this one, strike this one, strike that one, this one, and that one, so that this one can go with this one. So we'll have two numbers. We'll have 15 plus
25 divided by 2. But if
Is
there
that
were
right?
11, we would pick the middle
one.
number, right? Yes.
So now, let's get to have what are these? Let's have the mod. What's the mod?
The mode, that's the number that is appearing, maybe. Hello?
Yes.
Frequently appearing number, something like that.
Yes. So the mod is actually the most
15.
frequent.
Yes.
15 is the most
Number, which
number.
is 15. Yes, 15.
Okay. Then we can use them to describe the distribution of data. What was the mean?
The mean was did we add everything? No, we didn't. Did we?
We didn't.
We
Anyway,
didn't.
it's fine. So the principle is that if the mean is equal to the median and to the mode, then the data is symmetric. When the data is symmetric, all of them are equal. Okay. Understand? But if
Yes.
the mean is greater than what's this? The median is greater than the mean. Okay. Then the data is tilted to the right. But if the median is less than, if it is less than the mean, then the data is tilted to the left. It's left skewed.
Oh, okay.
Now about the standard deviation. Calculate the standard deviation of the test results. We may not find the standard deviation if you don't have the mean, because to find the standard deviation, we have to do this. I have to say the summation. If you still remember, do you even start?
I remember. There, so we can do 10 minus the mean. If we added, we would have known the mean. Yes. Over 10 minus 1 under the n minus 1. That's 10 minus 1. Then we add all these numbers. We add them. And then we...
So I've said 2.4 minus the mean. We square that plus
yes.
10 minus
10 minus the mean. Yes.
Until we finish all of them and divide by n minus 1, then we square root.
10 minus, yes, then we square root.
Yeah. Oh,
I know.
remember.
Then the variance is the square root of what?
When we don't square like this, if you don't square, this is the variance.
This is the variance, yes.
If you don't square,
then
but
the standard deviation is the square root of the variance.
Yeah, and a square root.
This I know. I remember.
These simple things are the ones that bring troubles. Okay. Calculate the 10th, 15th, 50th, 75, and 90th percentile and interpret the result. You know how we find the percentile? So it's the number of percentile divided by?
This one I don't know.
So it is the number of percentile that has been said divided by 100 times n. N is 10, like the number of the scores, how many they are. Okay.
Okay.
What this will give us is an index. What it gives us is what? Is an index. An index number. This index number is just giving us the position of the position where we can find that actual number. So if you find a whole number, then you have to add that number plus the next one. If you find the number is not a whole number, just round it off and get the number. Okay, let's have the index so that you understand what I mean. So in this case, 10 out of 100, 10 over 100 times 10. You said the scores are 10? Giving us what? 1, isn't it?
Yes, 1.
1. So first of all, you have to arrange these scores in ascending what? In ascending order.
Oh, okay. Okay.
Yeah. So what is there is that it means that the 10th percentile is on position number what? 1. Okay.
Oh, okay.
When it is on position since this is like this one is just an approximation of a position. Since this one is a whole number, so you get the number that is on 1 plus the next one and average them. So the answer will be 2.4 plus what? 10 divided by 2. That will be the 10th percentile.
Go back.
Okay, just a minute.
All right.
Yeah. So basically, that's how you do it. So if it's the whole number, you count the numbers that are arranged. Then that number which is appearing, this index number, plus the number that follows next, you average. That is the percentile. So what is the percentile?
Hello?
Hello, what's the percentile? Add 2.4 plus 10 divided by 2.
7.4.
7 point what?
4.
7.4. 7.4. So 7.4 is the 10th what? Percentile. So we are trying to divide this data set in terms of percentages. That's what percentile means, in terms of the percentage. Okay. So it shows that 10%, like 10% of the values, 10% of the people, they got 7.4 and below. You understand? 10%, yeah, of the people, they got this value. These were the scores. You get it, eh?
Yes.
So that's what it means. So 10% of the people got 7.4 and below. Now we go to the next. We go to the next one. The next one is the 25th percentile, right? You just say 25 divided by what? By 100, which is same as 0 times 10. I think this will give us 2.5, right? When you look at 2.5, this one is now a decimal. So being a decimal is an index which is a decimal. You round it up to a whole number. You get round it up to a what? A whole number. So it will be 3 in this case. So since it's already a decimal, you've rounded it up. So it means that the number which is on position number 3, like the index is just showing you the position, will be
The position. Oh, okay.
the 25th percentile. So in this case, the 25th percentile is what? Is 15.
15,
right?
yes.
Is that right? You can do for the 50th percentile. You can write on this screen. You know that, eh?
Last time I didn't manage.
No, you can manage now. Being shared. Just try to write it. Last time I didn't manage. Calculate. What is the 50th percentile? Are we there?
No.
We're not here. Okay, so they say this n divided by what? Oh, let's say this number is k. If the number of the percentile divided by 100 times n.
Times 50, yes.
So 50 over 100 times 10. Our n is 10. What is the index?
So 5. So fifth position. 1, 2, 3, 4, 5, 15.
It's 15 as well, right?
15. Yes, so 15.
Now, since 5 is a whole number, what do we do? So we can add this 15, which is on number 5, plus the next number, which is again 15 and average. You got it?
Yes, so give us 15.
Yeah. Any question? There's no question. We did probability, huh?
Yes, we did. I think that's where I'm finding challenges.
Let's start from here. Question number 4. Suppose you have the following information about the probability of clients purchasing two goods A and B. What is the conditional probability of buying A given that they bought B? Interpret the answer. So you remember what we said about the conditional probability? We said that it's the probability of getting or finding an event given that another event has already occurred, or the probability of an event occurring given that the other one has occurred. So the probability of an event A occurring given that B has already occurred, you're following?
Yes.
It shall be equal to the probability of A intersection B divided by the probability of what? What did we say? Which one will be your denominator? This one that you have been given, okay? Yes, that's how you state the condition. So what you are asking to find is this one. Is you start with the one. Then what you are given, the condition that you have been given is what you put under. So if it was the question of what is the probability of buying B given A, it would have been buying B given A. You get it, right?
Oh, okay.
The probability of B intersection A over the probability of what? A. This one, what you're given is your denominator, okay?
Oh, okay.
That's how you deal with conditional probability. And let's see, let's now put answers. It's very easy. What is A intersection B? It is 3 over what? Over 20, right?
Yes.
Divided by B, right?
Yes.
The probability of B is 1 over 4. Then you solve. What's the answer? 3 over 20 times 4 over 1, right?
3 over 20 is 0.15.
0.15, right?
Then 1 over 4, 0.25.
Yeah, we can still leave it as a fraction. Can
Oh,
leave
okay.
it as a fraction. So 3 times 4 obviously it will be 12 over 20. When you reduce the fraction, it will be 3 over 5. Right.
Oh, okay. All right.
This is the probability of getting A given B.
B. Okay.
They asked the same question down, the reference. You can do this one. This one.
Mm-hmm.
Will you solve this one on the screen? What we are sharing.
Probability, is it not B over A?
Mm-hmm. So what is the probability of buying B given A?
Mm-hmm.
So probability
So A
of
is the
buying
denominator.
B given B. So it shall be the probability of B intersection A given the probability of A. What is the probability of A intersection B or B intersection A?
1 over 4 times 1 over 5.
Are we given the condition of what the event is all about?
A.
Yeah. So what you're giving is mutually exclusive events. We're not told that these events are mutually exclusive. Anyway, get it that A intersection B is same as B intersection A. They are equal.
Oh, okay.
It's one of the laws of probability. So we still put the same answer. Okay? So it will be 3 over 20 divided by what? 1 over 5.
1 over 4 over 5 for A, yes.
It will be 3 over 20 times 5 over 1. That will be 3 over 4, right? You've got 15 over 20, then you choose the number that can get into that, 5 into 15 is 3, 5 into 20 is 4.
4, yes.
Does that help?
Yes.
Okay.
Condition.
Are the purchases of A and B independent events or not? Explain. Are they independent events? Are they independent events? Okay. So they have an intersection, right? They combine at not independent. B.
Okay.
Due to increased road traffic accidents happening countrywide, the Road Transport Safety Agency, RATSA, conducted written as well as actual driving tests to minibus drivers in Lusaka district. They found that 3 over 5 of the drivers passed the written test. 3 over 5 passed the test. How many failed?
2.
Right, it should be 2 over 5, isn't it?
Yes, 2 over 5.
2 over 5 failed. Okay. Further, they observed that only 166 over 200 of those drivers who passed the written test passed the actual driving test. So there is a written test and the actual test.
Oh, okay.
Right? So it is possible for a person to pass the written test and fail the actual test.
Oh, okay.
They went further to analyze the results and found that among those who did not pass the written test, 75 of 200 of them passed the actual driving test. So 75 of them passing the actual
driving test.
Now, construct a properly labeled probability tree of this situation, showing all the probabilities. Ensure to show how you have computed all the missing probabilities included. End of test. So this is what we call the conditional probability and Bayes theorem. With this one, what occurs is that, let me just read, show you to understand. So I need you to understand this such questions. It's like these are overriding situations. You understand what I mean by overriding? When a situation happening, then there will be a further situation happening, like they are aligned. For example, there is a probability of coming in class finding people who are maybe HIV positive and others are negative, right? There is a probability. The probability of finding someone positive, maybe let's say is 40%, which means 60% they are negative, right? Then when the test is done, there is a probability of the test giving correct results or wrong results. That is to say, they can diagnose that the person is sick when a person is not even sick. Or they can diagnose that the person is negative when the person is what? Positive. You understand? So the tree is like this. Let me give you this one for positive and negative so that you understand. We have a probability of those who are positive and negative. Among those who are positive, the test has been conducted now in the second tree. They find that someone has been diagnosed positive because he's positive. Someone is positive but has been diagnosed negative. You understand? Then again, it's possible someone is negative, then they are diagnosed what? Positive, like the machine makes a mistake, or again, it gives a negative to someone who is negative. So the true results are these. It should give you positive when you are positive, or negative when you're negative. But we have situations of these mix-ups. Have you seen the tree, how the tree is coming out? Now, let's go back to the actual question. We have a probability, right? There is this probability that 3/5 of the drivers pass the written. So the first thing, what comes first? You have to understand what is done first. That is what you put on the first tree. Okay. What is done first? Is it a written test or the actual test? It's written, right?
Written test, yes.
So there is passing written test. Or failing the written test, isn't it? Then afterwards, it's possible to pass the written test and again pass the actual test. Or fail the actual test, isn't it? It is possible to fail the written test, but pass the actual test. It's possible. Like people have, there is this probability. They said they went further to analyze the result and found that among those who did not pass the written test, meaning they failed it, 75 over 200 of them passed the actual driving test. So it's possible. Then again, it is possible to fail the written test and fail the actual test. You fail everything. Have you seen the way how the tree is coming?
Yes.
So now let's put the probabilities. What is the probability of passing the written tests?
3, not 3 over 5.
3 over 5. So what's the probability of failing?
2 over 5.
2 over 5. What is the probability that a person who passed the written test also passes the actual test?
It is not 75 over 200.
Read the question. You pass the written test, you also pass the actual.
Oh, 166.
Yeah. So
over
further,
200.
they observed that only 166 over 200 of those drivers who passed the written test passed the actual test. So it's 166 over 200. How many failed?
30, should be 34. 34.
34 over 200.
Over 200.
Right. Now we're looking for people who failed the written tests but passed the actual test, right? They did not. How many are they?
You said who failed?
We're on this tree. You first fail the written test, then you pass the actual test.
$75 over 200.
75 over 200. Okay. What about those that failed everything?
Well, 125 over 200.
125 over 200. Any question?
No.
Is this hard? So just understand the riding conditions. So the first thing is to establish what is the first event. There are two events combined together. So understand the first event in the question. When you pay attention to the first question, event, you catch it properly, then the rest can be very easy. Right? Let me give you another one so that you understand. Just a situation, I want to put a tree. In a class, okay, in a class, 60% of the students are male. 40% are female. You're following the question?
Yes.
Out of these students, okay, it is given that we have 40% of these male students who are vegetarian, right? They're vegan. Which means the other percentage of these male are not what?
Vegan.
They are they take flesh. Right? And we are also given that other group who are female, we also have a percentage of them who are vegetarians. You get the point?
Yes.
So in this case, there are two events. It's either, first of all, You have male, female, that probability. That will be your first tree. Then from there is the issue of being a vegetarian or flesh taker. You get. Yeah. So understand, this is how we come up with the tree diagrams. So now, if you want to find the probability of the people who failed, how many people failed? What is the probability of people who failed?
Hello?
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 Yes, I can hear you.
What is the probability of people
I
who
couldn't
failed?
hear I couldn't hear what you said. Someone was calling.
Okay, I'm asking that what is the probability of failing? What is the probability of people who failed?
Okay, I've lost you there. The last time I checked, you were talking about male, female, then vegans and non-vegans.
Yes. So I was asking, I was showing you that there are two conditions there. There is a probability of first being male or female. That is in the on the first. Then on the second tree, you can either be vegan or non-vegan.
Or non-vegan. Oh, okay.
Yeah. So we have two events to be represented on the. Yeah.
Oh, okay.
So now we go back to this question that we have. What is the probability of those who failed? How can you find the people who failed?
It three over on this same question, 34 over 200.
Okay. And which one?
125 over 200.
Okay. What about 2 over 3? Didn't they fail these?
2 over 5.
Right. So let me just be quick to indicate here. So when they ask you what is the probability of finding people who failed? So failing is like this. It's either they failed the actual tests, given that they also failed the what? The written tests, plus they can fail the actual test, given that they passed the written test. So we are asking for the probability of those who failed the actual test. So they can either fail the actual test, but they passed the written one.
The written one, okay.
Exactly. So this is how you find the probability. You multiply.
Oh, okay.
So the probability of fail given the actual test times fail given the written test. So you multiply these branches, the fail ones. Okay. So you say it will be 2 over 5 times 125 over 200. You get
200, yes.
Plus here fail actual test times the written pass the written one. So it will be 3 over 5 times the 34 over 200. So solve this. Find one figure here, find one value, also this side, and then add them together. You get it? What is the probability that the person passed the actual test?
Pass the actual test.
Mm-hmm.
Is it not 166 over 200?
Okay.
Yes.
Is that all?
And also 75 over 200.
Okay. So passing the actual test, you can pass the actual test given that you also pass the written test. So it will be the 3 over 5 times
over 5 times
166 over
166 over 200, close brackets, 3 over 5 times 75 over 200.
Yeah, that is how you deal with this. They are very easy things.
Mm-hmm.
Any question?
No.
These are fun questions that people can ask you. What is the probability that people pass the actual test? You should understand that passing the actual test has got two streams. You can either pass the actual test but you failed the written one, or you can still pass the actual test given that you also passed the written. So these are the conditions that you deal with here. Are you fine now?
Yes.
Okay. How did I got the last test? Oh, this is the one that we had. What about this one? Oh, these are the types of the scales and variables. We didn't meet such. This one I gave you last time to deal with, eh? Question number 2. You remember this one? Condition, what topic was this? Do you remember? Hello?
Hello.
What topic was that?
I've forgotten, and we did it recently.
It was binomial probability distribution.
Okay.
And actually,
But
it was
how
the
do you
accuracy.
tell? But how? That's the problem that I have. How to tell, like the type of probability. So
You
like
look
it
at
means
the
I can't even
information that you
tell.
have been given. For
Mm-hmm.
example, if it's binomial probability distribution, we said that
Mm-hmm.
you'll be given the probability of success in one independent trial, right? One
Mm-hmm.
independent trial. 2, you have fixed the number of trials. It will be given in
Mm-hmm.
the question. Fix the number of trials,
Mm-hmm.
okay? And the probability of an success in each independent trial does not change. So it will be fixed throughout. So for example, your question has already given that 30% of all customers who enter stores, meaning it's fixed. Every time customers enter, 30% of them, they will purchase, they'll make a purchase. That is our P, right?
Mm-hmm.
So something like this. Okay. 1 minus x. Yeah. So, yeah. Suppose that you have 6 customers. So it means your N is what? We said your N is 6. That's a total
Mm-hmm.
sample. Yeah. Of these. Now, what is the probability that exactly 5 will make a purchase? So your small x being what now?
5.
5, isn't it?
Mm-hmm.
Get x being 5. Your P
Mm-hmm.
is 30% being 0.30. Then you substitute it
Yeah.
into this formula. Is it not what we did?
Mm-hmm. Yeah.
I also gave you to try.
1 minus P.
Remember, n x p to the power x 1 minus p raised to the degree n minus x. Just check the recordings on binomial. Actually, we even did this and as a recording. It's part of them. I
No.
shared this question. Maybe about this one, the contingent table. What topic is this? I like the way how I taught. Everything is related now. What topic is this?
Is it linear regression? I don't know.
Okay. So this
Ah,
was the chi-square.
guys.
Okay, it's hypothetically correct
Oh.
using chi-square, using a contingent table.
Oh.
So you already have the observed values. What do you need? Remember how to find the chi-square.
Mm-hmm.
You need the summation of observed value minus the what? The expected
The
values.
expected values.
Square
Yes.
that divided by expected values, isn't it?
Mm-hmm. Yes.
These are already observed values. To find the expected values, you multiply now on a contingent table. That
Mm-hmm.
times that divided by this. It will give you this one, isn't it?
Mm-hmm. Mm-hmm.
Is it or not what we were doing?
Yes.
What do you find?
24. 8 point.
34 times 16 divided by 66 is 8 point what?
8.24.
Okay, 8.24.
24.
Then the other one, which will be this times 16. 32 times 16 divided by 66.
7.76.
7.76. 7.76. What about this one? 34 times 15 divided by 66.
7.72.
7.72. What
Mm-hmm.
about the other one?
34 times. 18.03.
18.03.
Mm-hmm.
What about this times 35? 34 times 35 divided by 66.
That's 18.03. Which one did we miss?
Did
There
you
are three.
do
So it's 18 point.
did you do 34 times 15 over
Yes.
6?
Yes, that's 7.72.
Oh, 32. Did you do 32 times 15?
No. 32 times 15. 7.27.
Okay, 7.27.
Mm-hmm.
What about the last one? This one.
16.96.
16.96.
Mm-hmm.
You get it, right? These are the
Yes.
expected values. So if you want, you can have the actual values, these being 12, 4, 9, 6, right?
Mm-hmm.
13, 20 what? 2. Then with
Mm-hmm.
the observed values, okay, These are actual values. These are observed values, sorry, the expected values. For this one is corresponding to
8.24.
Then this one, 7.76.
18.03.
0.73 and the 7.27, 18.03 and the 16.96. So from there you can now do the right thing, whereby you do 12 minus C, which is the the observed values of these. Just follow through this formula. 12 minus C,
8.24.
You square that, divided by what? 80.24. Plus, you go to the next figure, you get 4 minus 7.76. You square that, divided by what? 7.76. Until all of them are finished, then you find the calculated what? Chi-square, is that right?
Chi-square.
Then to find the actual chi-square, you use this value, the alpha level, which is 9 at 1%.
Yes.
And I said with a chi-square, there is nothing like double tail or whatever. It is just single tail to the right. So since this is a continuous table, you need the degree of freedom. Okay. So you already have alpha, comma. Now you need the degree of freedom. That is given by the number of rows minus 1 times the number of what?
Columns minus 1.
How many rows do we have?
It's 2.
So there are 3 rows minus 1. How many columns? Columns are these that are vertical. Rows, they go horizontal.
2.
Okay, 2 minus 1. So that will give us 2 minus 1 is 1, 3 minus 1 is 2. 2 times 1 is 2. So it will be, the alpha one is 0.01, comma 2, isn't it?
2, yes.
2 is the degree of freedom. So when you go to that table, you check where there are degrees of freedom, where 2 is. And on top, that is the chi-square.
Where there is 0.01.
Where they meet, you get that figure. That's the critical chi-square. Okay? You will put it on a table like this one, that critical chi-square. Then you compare it with what? With the calculated chi-square that you have found. You get it, right? If the calculated one is on this side, you reject the null hypothesis and just like that. You remember now?
Yes.
Okay. It's very important to go through when the SAR had thought. Okay? What is this now? Draw the scatter plot. This is the regression analysis.
Regression, yes.
I was talking about this. You know how to do a scatter plot, even know how to comment on the observed relationship. So if it's positive, just draw it. Draw a scatter plot for this one. Okay. First of all, let's just establish which one is the x-axis. Actually, they've already given.
No, yes.
It gives the average hourly dose temperature. Temperature is x. So this is our x, this is our y already. So these will be on horizontal axis, like that. Here there will be temperature, there will be consumption. Okay. And then you plot. Whatever trend will come down, it will show you whether it's moving like this or like that. Just follow the trend. And you know how to interpret, right? If it's going like this is positive, what? Related, right? There's a positive correlation between them. Then if it's moving like this, there is a negative relationship. So you can always comment on that. Estimate the regression equation and interpret the slope and the coefficients. Obviously, you need the calculator to estimate this. And
Yes,
I sent you the video.
that video, it's not clear.
So now how are we going to do it on a calculator?
I don't know because it's not clear. I tried to go through it in the afternoon, still I couldn't see anything.
I couldn't see anything.
Yes.
You couldn't hear anything. I do think you need to watch it actual on the website. You even increase what that you know how to set the video on the web. Like you put quality. There's a part where when you're watching a video, right? If you're watching a video, there's a part where you can set to increase the quality. Let me try.
Okay.
Let me try to do this. And now I'm afraid about try this. You can now see the screen, right? Are you able to hear me?
Yes.
Or you have stopped hearing me?
No, I can hear
you. And can see the screen. Can you hear me again?
Yes, I can hear you.
What is the name of the course? Business statistics. I don't think so. This man has taught a lot of things. Do you visit the web? You usually visit the website. See what you have done. Are you able to see this video?
Yes.
And are you able to hear it?
Hello?
Hello?
Yeah, I can see.
You can see it.
Yes.
Let me do this. Have you seen what happens? When you press on the screen, there is this part where it shows settings, right? Are you able to see the
Which part?
settings? The far corner.
Yes. Yes,
You've
yes.
seen the settings.
Yes.
So you press on settings. Then the first part what comes is what? Quality. Have you seen that?
Oh, yes.
You press on quality and you advance the specification. So you can advance the quality of the video. Okay. And you can hear what the video says.
No.
Oh, you can't just hear it, right?
Mm-hmm.
You can just hear me. Okay. So when you increase, because generally you just need to know what goes on in the calculator. Oh, and you should pay attention to the words, I think, because the words are very clear.
Oh, okay.
Okay. Just follow the words very clear because they also give the instruction. Can you go to the mode? From the mode, press here, press number. So just pay attention to the voice and press the numbers as I am speaking. You will get it.
Okay.
Yes.
All right.
Pay attention to the words. That's that's the most important thing. Then you can do regression analysis. Yeah. And the interpretation things are not a problem. Then from there. Okay.
Okay.
Okay, stem and leaf. Did we have the stem and leaf on your? No, we didn't have this one.
No, no.
Poisson distribution. You never had this one. We had it. Question number 3. This was an
Question 3,
exam.
yes. Yes.
It was even an exam. So we have less to revise, eh?
We
Most
have
of
a
the
lot.
things,
Probability each.
probability is giving you
Yes,
problems.
and we need to go through NIPA past papers.
You have gotten them. Have you
I
found them?
sent one. I think I'll try to send another one. I think I sent you one.
I haven't seen any.
Oh, okay.
Hypothesis testing. Actually, this one was an example. It's one of the examples that we used on hypothesis testing using using the chi-square, not the chi-square, the OASIS. The sample size is 60. They're using the Z distribution. Using the Z distribution on this one. And how to calculate to make the confidence intervals. That's no longer a challenge with you, isn't it? Using the
No.
mean. Yeah. So okay. Then you can do this, Kansh. You can do this. I can share with this. You can we have the scatter plot here. What are they saying? Can you interpret the entries? Obviously, we know the relationship is positive, isn't it?
Mm.
Can specify the regression line here, and this is very easy. You already know it.